back and picked up this thing for free. It's a Sine Master Kipor. It's got a so it's an inverter generator. So it's got a little gasoline engine, 4-stroke, and an inverter. And the common problem with this particular brand, it seems, is the engine will run forever, but the inverter goes, and that's what's happened to this one. You get a fault when you start it up. And I haven't run this in about a year, but when I first got it, I put some gas in it and it ran well, except for it doesn't generate power. So I was kind of, you know, toying with the idea of just tossing it away, but I hate to have it. You know, I mean, there's an engine that runs good, you know, and at a minimum, I could use it just to burn fuel, right? Because it'll do that. But, I don't know. I'm just wondering if it's, you know, if I could ever figure out the coupling for it. And because I got a couple of generators, got like this old Champion here. The engine had problems, but the electrical end is good. And now how I know that is I borrowed a bunch of parts from another Champion that I had, and I put the rewind on it and the coil from another one, and I got it to fire up on ether, and it generated power. So, you know, if I could split this generator off of here, or maybe if I could take that engine off that little Kipor, put it on here, and maybe run this generator. But I don't know, it's probably not big enough. I mean, this is, I don't know what the cc's of this one is. This is bigger, but this is only 105 cc's. You know, I think it says, where did I see that? 105 cc's down here. Where did I see that a moment ago? Displacement 106 cc's, so it's not very big, right? It's not going to power a lot, so that's why I guess it, you know, it's well matched to just a little inverter. And but I'm curious about how it works, what it looks like with the cover off, and it falls right in with my wanting to just tear stuff to bits. So I might take a look at it, see if I can get this cover off, and because I know it runs. It did run. It ran for, you know, good 10 minutes or so, but then it had an electrical fault here, and I looked it up, and it'll always go into whatever this indicator here goes hooey, and it doesn't generate any power. So I'm just going to take this end off, see what it looks like in there, and you know, this is usually the way it starts. You know, you start on something, but let's take a look in here just to see what's in behind this panel. I'm curious about this because this is something I'm not used to. I'm not used to these. I don't think I've ever worked on an inverter like this, so I'm just curious about how it works and what could be wrong with it. Maybe it's just a connection. You know, I think I saw somewhere where there was a plug that was acting up, and that's all it was. It was just the plug that was malfunctioning, and the guy got it to work. So I think I'm gonna have to split the case, so it's a whole bunch of fiddling around to get the case apart. There's a bunch of little bolts there. This looks like it's been rode hard and put away wet. It's pretty filthy. So maybe that's part of it. Maybe it's just, you know, it got exposed to maybe salt water. There's an ocean not far from here. So maybe someone had it on a boat, got salt water in it. Who knows? Maybe it's just a connection. Okay, I see from the other side there's some Phillips screws there. And there's some flats. Get this end cover off as well. Okay. I don't know how that comes off. Oh yeah. There's a circlip here, look at that. Huh? See that? Oh, it's going apart. Oh. Okay. Oh, there it is. Okay. So that's one hemisphere right there. Let's not get too technical here. Let's just call it one side, not a hemisphere, right? Okay. Now, Oh, take a look at this on this side. I'm gonna see what we have here. We've got, oh yeah, fuel tank here. There's the electrical bit there. Rewind. Okay, let's see if we can get the other side off. You can see there's a drain on the carburetor. Comes out that little hole there. That's just when you want to drain the fuel from the bowl, I think. Okay, so that's that. I think the main hang up right now is, I think this is a fuel shutoff. It says here engine switch on off. But when you turn that, it isolates the fuel from the tank, so I've got to deal with that. Oh, there's a screw here. Let's take that out. Okay. There we go. Oh yeah, so there's that panel, and there's the cover. Maybe we'll squeeze it out through there, I think. All right, this has got a screw in it here, so that's probably it. Okay. That'll reveal something now. Okay, button's off of there. Put that in there with its friends. Now what do we have? Oh yeah, you can see the fuel mechanism here. See, that valve does actually shut off the fuel. Okay, so it's caught in a couple of clips there. Okay, so what do we have to do to free it? There's a connector here. All right, so we can get that. Let's see, how's that done? Okay, probably have to take the rope out of there. Just don't see that going through there. Maybe. Oh, look at that. It does go through there. Look at that. Okay, so the gas tank just kind of falls down here. There's nothing holding it. And there's a fuel line here. Just got to be disconnected off the tank right here. And then we can move the tank out of the way. Yeah, we'll get that out of there. Okay. And so that's the fuel tank. We can just get that right out of there for now. Okay, and that pulls off of there. The filter out of there. It's quite well made, actually. You know, I like the way they've made it. It's it doesn't seem like junk, you know. Where's that little hose go to? Is that it? Oh, that looks like it. That's the other side. That's it. All right. All right, that's the other side. And that is your fuel pump. That's what that is. So this comes from the tank. Goes through that on-off selector switch. Goes to one side of the fuel pump. This comes from engine crankcase vacuum, must be here, and this is probably delivery on the other side. Yeah, to the carburetor. This one, yeah, this is discharged to the carburetor. That's this little hose here goes to the carburetor. Yeah, it's pretty good how that's made, really. Yeah. What's the other side of this look like? Oh yeah. Oh, there's a wire there. It must be ground onto the face of it. A couple of big capacitors. What's this say here? It's a KI-20 11 TI 60 Hertz. Yeah, okay. It's got 2007 at the beginning of the serial number, so maybe that's the year of manufacture. Now there's something peculiar. See the coil, you know, spark plug and coil, and see the legs on the coil. Well, they're not riding on the, you know, with an air gap to the flywheel. There's nothing there. This is on the outside of a plastic cover. How in the heck does that work? You know, how How's that work? I mean, the air gap would be, you know, 1/2 inch or something. You know, presuming the flywheel's right under there. And that's it. That's not me altering that. That's how it comes out. How do you figure that? Huh? How do you figure that? Wow. That blows me away that that coil's just sitting on there mounted on the side. Is that possible? Is that possible? Okay, I'm going to take the muffler off just to try and figure out how this is all put together. Not much of a socket, is it? Okay. Huh. That's how that sits in there. Huh. That's the cylinder head, I think. Yeah, the way that'd be the piston in there. This is your cylinder head. It's doesn't look like much, does it? Wow, a pretty thin piece of aluminum for a cylinder head, but I don't know if it's what else is. Yeah, it's kind of weird that they'd have a vent on the top here. That's peculiar all around. This is probably from outer space. They got this off of a UFO or something. What technology is this? This is not of this earth. This is not of this earth. A coil that doesn't run on the magneto. A muffler that takes up all that space on this side. A thin, probably not even aluminum. It's probably kryptonite or something. This cylinder head and a vent on the top of the cylinder head like you've never seen before. Where did this come from? Where did this come from? This is a generator plant off a UFO. Okay. All right. There's that, and there's the breather hose off the top of the crankcase. Ignition coil doesn't contact the flywheel, or doesn't come close to the flywheel. It's supplied with power here. It's kind of strange that they would use that type of a coil that doesn't pick up, you know, through here. But it looks like that's the way they did it. So we got our spark plug lead, and we've got a connection here we can disconnect like that, and that's that whole assembly right there. All right, there's a boot here, those wires. All right, now so this is the rotor, and the stator, you can just see the windings of the stator in there. So the stator stays stationary and the rotor rotates over it, and it creates alternating current. Brings it out here into this module, and it rectifies it to DC current, and then they take that DC current and they make AC current that is the final product that comes out here. And the reason they do that is if they were to take AC power off of here, it's not as clean and distortion free as if they would take it and rectify it and then invert it back to AC. That's the reasoning. Okay, so 2 bolts there, over that. All right, and we got our fan that comes out. go. That comes off. Oh, that's a very strong magnet holding that on there. Really. There we go. Oh, it hardly wants to let go of the magnet. Here's your rotor. It's fixed with permanent magnets all the way around. And here's your stator. It's bolted solid to the case of the engine. All your different windings. Yeah. And you can see the wires come down here. We can trace these out a little better. This little device right here, I think, is what they call the trigger. This is your capacitor. Now we can show you where that goes in a minute, but the capacitor, it just, what it does, it's wired here across the outlet receptacle. And what that does is it helps absorb any voltage fluctuations in the output power. It cleans it up and reduces electrical noise in that output power. By having a capacitor there, it acts like a little reservoir for variations in impulses that come out of that power, and it helps to stabilize them. So you end up with a clean power going out. This is your bridge rectifier. So I believe, if I looked on the, kind of look on the electrical diagram, there's one of these circuits in here. One of these windings is specific to providing power out to here. So it's AC in here, and AC goes into here and comes out as DC, and then it comes out to your DC charge port on the control panel right there, 12 volts DC, 5 amp. Okay, and then of course the other power that comes out is 120 volts AC out of here, and that's after. Yeah, they have this is kind of a strange way they do it on these inverter generators. It generates AC power here. This is just like an alternator, so I guess it's, in effect it is an alternator. So it's AC power is generated here, and then it's rectified to DC down in here in this converter box, module, electronic module box, whatever you want to call it, and then it is inverted from DC to AC for your final output. So it does it twice. So you've generated power here at AC, but you've changed it to DC, and then you've inverted it back to AC for the final output. And like I just said here a minute ago, that also has a capacitor that helps stabilize that voltage going out. So these are supposed to produce clean power, a pure sine wave power. So the sinusoidal wave for AC isn't square topped, and it's not jagged. It's supposed to be pretty well as close you can get to normal household power that's safe to run sensitive electronics like computers and things like that. Now, getting into the inner workings of the control panel is beyond me. Very often when these control panels, when they mess up, usually they're just a plug and play replacement, but they're several $100s, and I'm not going to spend that on this old generator. But we might be able to figure out a little bit better how they work by tracing out the wires and looking at everything. So I think that's what we'll do. And then once we figured all this out, we're going to put it back together, and we're going to run the engine, and we're going to test some outputs and check our resistance through the capacitor. We're going to check the capacitor for see what it's rated at and see what it's actually doing, and a few other tests all through here. So, and we'll also take a little bit better look at how that engine is. I initially thought that this was the cylinder head, but I looked at a drawing I can show you here. This is actually the valve cover. The piston, there's no cylinder head per se. The cylinder is machined out of the block up to here, And then above that is this is the valve cover. And if you were to take this valve cover off, you would discover the valves are in there, and also, surprisingly, a gear that drives the camshaft driven by a chain. So this actually has a timing chain. This tiny little engine has a timing chain that runs the valves. And we can take a peek in there. I'll show you that. Let's just take a look in there. It's unusual, yeah, but that's what they have in outer space. That's what they have on there. That's what they have on UFOs. It's not very strong. You know, it's not you know, not very thick. I thought that kind of curious if it was a cylinder head, but as it turns out, it's a crankcase cover, I guess you could call it, valve cover, crankcase cover, and you'll see that here in a minute. Oh, there you go. It's coming up pretty easy. Okay. There's a little gasket there. It looks like it's only silicone. I can duplicate that in a hurry. And this is your crankcase breather right here, and that goes to your air inlet. And here you are. Look at that. Have you ever seen anything like that in your life? Look at that. Look at those valves next to my finger, the size of them. And the little timing chain. And that's the camshaft with looks like there's two lobes on the one, two parts of the lobe on that one little short shaft. You can see how these arms go down. This one would be for the intake valve, and this is for the exhaust valve here. That's clever. That really is clever. Yeah. So we're not going to take it apart beyond that, but let's take a look at those valves as it turns over. Another thing that's really curious and tiny on this is the spark plug and the hole for it. Look at this, the hole for the spark plug. And look at that spark plug, how tiny it is. Okay, so turn over the engine, we'll see those valves move. Look at that. Oh, that looks like, my goodness, does it have a compression release mechanism? It looks like it does. Absolutely does. You can see it right here right there on the that lobe. So that's when it's cold, that interferes with the exhaust valve for a moment. Watch when it comes up here, and it's going to flick over that. You see it jump here, but whenever the engine's running faster, that's going to be out of the way, and it won't decompress that cylinder. That's pretty ingenious that they've even got that on here. So there's the, yeah, that's the, so here's the intake opening. Intake is opening, intake closing, exhaust going over that decompression right there, because there's that little thing right there. You see it right there, that little pin. And then you can see it actually on the other side. Right here is the mechanism, and it's a centrifugal weight attached to that little pin. So whenever it's running slow, like when you go to start it, that pin's interfering the intake open and closing, and then when I come around here, look, right there, you hear that click, that decompresses the this side for a moment, just momentarily, and that'll happen, as when the engine's cold. But as the engine starts, this little centrifugal weight here will move out, be thrown to the outside. It'll move that little decompression pin away from that arm right there, and so that won't happen once it's running fast. So this little engine even has that on it. Wow, it's pretty good. That's pretty clever. See, right here, it's going to do it again. There. Yeah. So there's the normal opening of the exhaust valve here, fully open. It closes, the intake valve opens, then closes, and then this is going to decompress right here. See that? That is so cool. And all in miniature. All right, look at the size of this. Now there's a couple of other curiosities with this thing. Now there's this load indicator, this output indicator, overload alarm, low oil alarm. Okay, now on the back, now the low oil alarm's pretty straightforward. There's a There's a little float in the crankcase. But something curious is in this little control in back here, the output indicator, the overload alarm, and the low oil alarm, probably the two top functions. See, it plugs in here, but there's a couple of capacitors in here. So I'm going to dig in a little bit deeper and see if I can figure out why they have capacitors in this particular little module there. And so what have we got on the back here? It's we have a switch for the smart throttle on and off. Okay, that'll, instead of running the engine the same speed all the time, it'll only run it fast whenever there's a load. So I guess that's what that's for. This parallel and output. Now, I trace those wires back. See these ones here, there's a black one, a red one, and they just go to the receptacle. See? That red one there goes to this side of the receptacle, and the black one goes to the other side of the receptacle. And I guess it's, what would they do? They light up when you got power there? It's telling you got power and output. I mean, it's sort of redundant, I guess, if you can plug in and have something there, but maybe there's another thing I'm not thinking of why they have that. But the most curious thing in here for me is, well, why they have a parallel port anyway. Why they have that? I'm not quite sure what is powered by that. Is why there's capacitors in this little block here. There's your main connection right here that comes out of your windings of your stator, and this little black one here goes to the top of the carburetor right here. These other ones go out to your panel. This one here goes to that indicator panel from here. This gray one, that's the parallel or the parallel port or serial port. Okay, so that just goes out to there. And this is actually the output. This is the AC output. And that just comes out, see, hot red and black to one side of the receptacle. And that receptacle is it's common to the other side. So when it's hooked to one side, it's powering both outlets. And what else can we figure out here? There's this little green one. Where does that go? That goes, I think that goes to the trigger. Yeah, so that's the whole thing. I did do a little looking around, and some people say that they have repaired these modules by simply disconnecting all the plugs and cleaning them and putting them back together. Sometimes they get corroded. Yeah, I don't hold out hope that that's going to be the case here, but I'll try it. And I did see another fellow who dug down through all this epoxy to get to certain components that are buried in there and fix things. You know, there's another guy actually changed a blown capacitor by doing the same thing. He unwound the capacitor and he ended up with the two terminals, and he marked them positive and negative as they are, and he hooked a new capacitor up and fixed his. But yeah, I don't know enough about it to diagnose that, but we are going to, once we've sleuthed out all these wires and figure out where they go, we are going to put it back together and run it and do some tests and see what type of output it's making. And yeah, we'll go from there.